Hi, my name is Stephen Hillian. I run data and AI for Astronomer. We're the commercial developer of Apache Airflow, which is sort of the standard these days for orchestrating data pipelines, data engineering and machine learning pipelines. How many people here are familiar with Apache Airflow, the project? Oh, okay, well, pretty much everybody, that's great. If you're not, don't worry, I'll explain a little bit more detail. Apache Airflow was created by Airbnb about 10 years ago for managing the flow of data throughout the organization. It was enormously successful. They open sourced it into the Apache Software Foundation. Now it gets about 35 million downloads every month. It's enormously popular. Probably one of the most successful open source projects in Apache's history, now even more popular in some regards than Spark. That's what we do. I actually have used Airflow myself for several years at Astronomer to build our own data infrastructure, so I'm an internal customer. And what I want to talk today about is really how to build a modern DataOps infrastructure. What's the infrastructure you need to build in order to manage your data pipelines well, whether those are data engineering or machine learning or analytics or operational data pipelines. Now, it's perhaps a little arrogant of me to think that I can just come in and sort of lecture people who probably work for organizations much larger than Astronomer. We're about 300 people, the data engineering team of about, data engineers and data scientists, about 10 of us. But what that team does, of course, is to analyze what our customers are doing, who are Airflow users. So we actually have a lot of visibility into what other data engineering and data science teams are doing to build out their data ops infrastructure. So what I'm going to talk about today is pretty much how we do it internally, but we mirror what our clients do. And so my goal really today is to say, prove two things. One, data ops is really important. Hopefully that's not so much news for the folks in this audience, but that orchestration, an orchestration layer like Apache Airflow, is the right foundation for building that data ops infrastructure. I want to explain a little bit about what I mean by that. And again, we're aggregating this from all of the observations. We run billions and billions of operations on our platform every year. And a pretty significant proportion of those, by the way, actually come from Databricks. So running Databricks workflows, Databricks notebooks, Spark jobs, SQL queries, and so on. Just quickly, how many people here are actually in or run data engineering or data science teams? So a lot of practitioners, okay. This is why you all look so miserable, because we all know how challenging it is to run data engineering teams. I know this firsthand. Now, why is this the case? At least historically, I think things have actually gotten better. This is sort of like my worst case scenario. But I think some of the challenges are you have very siloed, fragmented environments, especially in larger organizations where you haven't standardized. You'll have different platforms for running data and machine learning depending on the team that you're talking to. Especially, I think, in the data science and machine learning world, it's kind of the Wild West. Everybody uses whatever technology they want because they want the best models and the best outputs. That usually means then that you're managing some sort of infrastructure. If you're lucky, you're on, say, Databricks and it's pretty well managed, or you're using our version of an orchestrator and it's well managed. But often cases you're running open source projects, you're running raw Python code, and that means that there's a lot of undifferentiated work in just keeping those systems alive. And that means you need to make a big investment in the frameworks that you build. We work very closely with organizations like Uber, Lyft, Apple. These are organizations that have built infrastructure around Airflow that are really great. They're really great orchestration frameworks and data ops frameworks built around Airflow, but they've had to build those themselves, and not everybody has that level of resource. So there's a lot of work that you have to do to create those frameworks. When I say limited skills as another challenge, I don't just mean sort of hiring data engineers and data scientists. That can be tough enough. It's unclear to me these days about how easy it is to get a job as a data engineer. I think it's changed a little bit over the last few years. But what is definitely true is that data engineering and data science teams are kind of treated like support centers. People just lob requests over to data engineer. I see you laughing. Everybody recognizes this. And they expect that gets turned around in a couple of hours because they view what the data engineer and the analyst does is like, well, it's kind of like Excel, except you're doing something weird in the background with SQL code or with Python code. They don't realize that they should really treat it like any other software engineering organization. A request comes in, it's properly scoped, it's properly documented, and then you work on that for some amount of time, you push it out to a dev and then prod. Data engineering, data teams are no different in some ways than software teams, but I think that's not recognized, and so they get deluged with requests, and it's difficult to prioritize. Because of the siloed nature of this also, often data leaders are kind of flying blind. Not many teams that I know of have a complete view of the health of all of the data pipelines running through their organization and how they interrelate to each other. I think the notion of DevOps is very different from the notion of DataOps in terms of its maturity, which is the next point that I want to make, is that we've kind of solved some of the problems that I've just been talking about for application development teams, right? Going back a long time now, certainly I've been managing dev teams for quite a while, and I've seen things massively improve from the pre-Agile days through to Agile and the development of DevOps best practices. Not saying it's perfect for the software engineering world, but there's a lot of best practices established. I think those folks kind of know how this is done. They have a single code base, miraculous. They have source control, version control. They have automated testing. They have CI/CD. They have dev, stage, and prod environments. All of those things that you take for granted and that make life so much more efficient for app teams are not necessarily true for data teams. But it should be. DataOps is the exact analog of DevOps for the data world. The idea is that those practices that I just named around having a centralized tech stack, CI/CD, automated testing, data quality, CI/CD, promotion from dev to prod, all those things I just mentioned should be standard in the DataOps world. When I list off those things, by the way, I'm just curious how many people here on the data teams that you work on feel like you do most or all of those things pretty well, that you have a difference between dev and prod. You have automated testing and data quality tests. You have version control. Okay, yes, few. Okay, there are fewer hands than the previous questions that I've asked. So that tells me what is my sort of intuition, and also what we see in the data is that DataOps is still fairly immature as a practice. Okay, so here's my claim, is that data orchestration and frameworks like Apache Airflow are a suitable foundation for doing DataOps. Now, I don't mean that they are the complete solution to DataOps. You still have to take a out-of-the-box Apache Airflow open source installation. Well, you have to install it, you have to upgrade it, you have to build data quality testing and frameworks around that. But just as DevOps starts with automation and CI/CD, so DataOps starts with proper orchestration, by which I mean the orchestration of data pipelines across ingest, data engineering, analytics, data science, and machine learning. All of those should be coordinated and run on a common technical platform. And something like Apache Airflow is a pretty great way of doing that. It has become essentially the de facto standard for modern teams who are building up orchestration. And what I'm going to try and prove to you is that you can then use that to build an entire DataOps framework around it. So how does this work with my own team? Well, we do lots of things, right? We generate reports for internal teams. We have governance reports that we release to our board and to our investors. We actually have reports and dashboards that we send to our customers that are live. So we have operational analytics that we run. And then we also have predictive analytics, health scoring for our customers so that we know that our customers are happy, lead scoring for our sales team so that they know who to go after. So I've sort of taken sort of a bird's eye view of the type of workflows that we run and sort of smushed them all together in one slide. We don't always do everything from ingest to machine learning. Sometimes the end result is just another data set or just a report. But this is sort of like the global view of what we do, the gestalt of Airflow at Astronomer. We start with flows that do ingestion and transformation of data, basic ETL workflows. Airflow was built for that. It's the bread and butter of Airflow, usually running Python, PySpark, or SQL code to push things through a data warehouse or a data lake like Databricks. Then you have workflows that are particularly dedicated to taking the output of those, doing feature generation and building and training models. So the training of models on a regular basis, say on a weekly basis, to update your lead scoring and to reflect the current business environment. Airflow is a really great way of making sure that those run, triggered maybe by the availability of upstream data sets, or maybe triggered by the accuracy of a model going down. Which brings me to the third type of pipeline, which is pipelines that actually push operational analytics out, often through a machine learning model, and then monitor that in production. So these are three very common uses of Airflow. The first one, ETL, feature generation, is by far the most common. Then you have machine learning. I would actually say machine learning inference is probably the second most common, and then the retraining of models only in the last, say, 3 or 4 years has become pretty common. Right now, across Airflow users that we see by surveys and by looking at our data, we see that of all the teams that use Apache Airflow, about 50% of them use it for model training and model deployment. So it's becoming pretty common. So that's the type of thing that we do. Airflow DAGs, Python generated, running these sorts of workflows, usually leveraging Databricks notebooks, Databricks workflows, Databricks jobs, and then also in relational databases, Databricks and others, SQL workloads. Those are by far the most common things. I've seen crazy Airflow workflows that are like generating support cases and routing them to the right people. Nothing data related at all, just pure analytic, pure operational workflows, but mostly these sorts of data pipelines. And now increasingly, we've seen this in about probably 10% of our customers, the use of Airflow for generative AI use cases. Not so much the serving of the models, although definitely batch inference with LLMs is becoming more common, but often the provisioning of data for those models. So even some of the largest vendors of LLM services, probably the one that you're thinking of right now, actually use Airflow for providing the data into the models that they build. Those models get built like every 3 to 4 months, so you don't really need Airflow for doing that. It's not like a regular schedule thing, but certainly the provisioning of the data into the models, very commonly Airflow is for that. And for RAG type applications where you're ingesting data from lots of, say, different documentation sources and so on, and then chunking that, vectorizing that, putting that into a vector database, that's a pretty common use of Airflow as well in the generative AI world. Okay, so that's what orchestration means for us. How do we actually get that done? Like, what's the actual technical layer look like? Well, if you've ever used Airflow, you'll know that you can just write Python code. It's data pipelines as code, configuration as code. That's how most people write their DAGs. We've actually decided that's a little bit too much overhead for us. We've created a sort of notebooks interface. We've got a version of this actually now that has Gen AI prompts built in so that you can actually forget about what Airflow is doing and just write sequences of Python code, PySpark code, or SQL, and then we'll chain that together, figure out the right inferences, and build out the DAG for you. So that's the first thing that we've built around Airflow to make it easier to build the pipelines. Then the actual DataOps stage is we will check in those as, say, part of our asset bundles, along with our Airflow DAGs in the Databricks world. We'll check those into GitHub. Those will exist on a feature branch. Those will then get deployed to a dev instance of Airflow, which is then usually in sync with, say, your dev catalog or your dev schema in Databricks and your dev workspace. So it's this sort of horizontal layers of dev to stage to prod, which are automatically integrated with source control. And then we can also handle the management of variables. So for the end user, I'm running, say, my SQL queries in my dev schema, in my dev branch, and then I do a code review, I verify that the numbers look right in the dev instance, and then push that out to prod. I barely think about Airflow. I even barely think about Databricks at that point, because we've integrated the CI/CD process and the environment management and the management of connections and variables so that that promotion from dev to stage to prod happens automatically. We have really good reference examples at the Astronomer website and on open source Airflow for how you can do that. It's a very simple concept, really, to match your branches to your Airflow deployments, to your workspaces, to your schemas, and then to branch those out, dev, stage, prod for each team. But it's a very powerful idea, and I'm happy to talk more about that at our booth if you're interested in more details about how we do this. But it's been very productive for us. Just to hammer it home, we started with really just checking into GitHub, deploy to Airflow, and deploy out to a workspace. Then introducing the notion of branched deployments, and then actually having separate workspaces for different teams with shared schemas between them. So this is now the way that we sort of manage our data mesh, which is a very grand term, but we make it very simple. A data mesh for us is simply a set of workspaces and catalogs with dev, stage, and prod in each of them, and one per team, usually with some sort of shared schema. The core data warehouse shared across everybody, and then each separate satellite team sharing a single schema where they can publish their data sets, their data objects. This has been super productive for us, as I said. We've gone in the first few months of spinning up my data team at Astronomer, just a few hundred jobs a day, to now running about 15,000 a day. That was actually a couple of years ago. Now we're at about 30,000, about a million tasks that we run every month. And it's a very small team, as I say. We've certainly got customers who are doing much larger than this. But my point is here, by having sort of built that right foundation, it allowed us to grow very quickly and be able to get rid of some of those skills gaps that I was talking about at the beginning, because we're able to really turn things around from an idea in the morning to something running in dev in the afternoon and then push to prod the next day. To do that, as I said, we've largely used open source Apache Airflow as our foundation. Orchestration first mentality is how we think about it. We build a lot of layers on top of that. I showed you some of the authoring that we built. We've got test automation frameworks that we've built around Airflow. For data quality, we've got a data catalog that we can sync with the Unity catalog. We've expanded out to ML use cases. We very much mirrored the progression of other teams. I work very closely with Lyft, for example, as one of the biggest Airflow users on the planet. They also built these sorts of layers. I think we both realized over time we need to build this into a managed service. So that's essentially what Astronomer does, is we've collapsed all these layers into one managed service for orchestration. And if you're interested in learning about what this actually looks like in the Databricks world, we've got some demos at our booth right over there at the entrance to the expo hall. But really, my point is that if you start out, especially if you're in a newer team or you're looking at new projects as part of a larger team, taking a look at Airflow as a way of managing the orchestration of your data pipelines across all your different estates, different teams, ingest, data engineering, data science to machine learning, is a great foundation to build. And whether you go with us as a managed service or just continue to build your own frameworks around Apache Airflow, it's a pretty great way of making sure that you have sort of a organized and structured way for doing data ops. Okay, thanks for your time. Complete your surveys. And if you have any questions, I'm happy to chat afterwards or over the booth. Thanks very much for your time.